further ado, I'd like to introduce today's speaker, Carey Coglianese. So Carey, I'm going to stop sharing my screen now, and you should be able to share yours. And also, I apologize if I mispronounced your last name at all.
Very much for the opportunity to be here. I'm happy to talk today about rule and permit design. You could advance. Can you hear me? All right, great. So just let me start by saying I think that most people understand that there's a taxonomy of regulatory problems, often captured under the rubric of market failure. If you're familiar with Circular A4 from OMB, you know that they outline these basic market failures of externalities, concentration of market power, and asymmetric information, and of course environmental problems are problems of primarily of externalities. But what, if you could advance it, Paul, what I think is important to see also is that there's need for a taxonomy of regulatory solutions. And I start by thinking about regulation as relational. It's a relationship between a regulator and a target. And that relationship is defined by a rule or a command that's backed up with some consequences. And that's what regulation is. So advance. What I'm going to talk about today is this part of that regulatory relationship, the design of rules themselves. These rules can appear in the documents that appear in a federal register called a final rule, or they can be specified in permits. And so that's why the focus of today's session is on rule and permit design. You can advance the slide. Design of rules matters just in the same way that design of buildings matters. We know that a building's performance, whether it will stand in an earthquake, or whether it will protect its occupants, whether it will be energy efficient, whether it will be aesthetically pleasing, what all of the elements that we're looking for in a physical building are affected by its design. And the same is really true for rules themselves. Advance. So if we think about why permit and rule design, I think it's because the different ways that they are designed, advance, will affect the degree of flexibility that regulated entities will have, advance. They can affect your ability, if you're at EPA or a state regulatory agency, your ability to enforce carry out those rules. And they're going to tax the capacities of the firms themselves, but also advance capacities and capabilities of the regulator to monitor and enforce and advance. And then ultimately, this means that different designs will yield different kinds of outcomes, different benefits, and different costs, depending upon how well the rule and the permit design fits the particular problem. Now, I should say at the outset that a lot of the work in environmental rule development and permit development is often, in a sense, hardwired by statutes that already dictate the basic design elements that I'm going to talk about. But what I want to present to you today are the results from a National Academy of Sciences study, and you can advance, that was published about 2 years ago, that I played a role in developing this report that provides a conceptual ordering to rule design. And it may be that in the particular context within which you work or particular permit or rule that you're developing, the statute is already hardwired. A national ambient air quality standard has been determined to take a particular form by the Clean Air Act, for example. The requirements for certain kinds of or a ban on defeat devices in automobile emissions, for example, that's something that's already specified and hardwired as taking a particular design. But this will not always be true. We have new environmental problems that are emerging, maybe even on the horizon, that will call for different kinds of designs where the agency will have discretion to choose. And there's always the possibility of other existing problems that where there is discretion by the agency on how a rule is designed. Overall, what I hope in presenting the results of this National Academy of Sciences report I can provide to you is a clear conceptual ordering and framework for at least thinking about the design of rules and the requirements that are found within environmental permits. I want to give due credit to the full committee for much of what I'll present, although I should also say that much of what I'll present and much of what appeared in the committee report draws on research that I've been doing for the last couple of decades. This particular report was commissioned by the U.S. Department of Transportation and the Pipeline and Hazardous Materials Safety Administration, PHMSA. And we did several case studies in the report and provide these of regulations of pipelines and offshore energy development. Even though the focus in those case study reports are on those two areas, the conceptual framework that I'm going to offer today is something that can apply in any particular context. So whether you're working on air, water, groundwater, hazardous waste, toxic chemicals, whatever the area you're working on, I think the framework that I provide will be useful. Let me start by just advancing, if you could advance to the next slide, by putting forward an appendix that appeared now nearly 20 years ago in an article on environmental regulation in the Duke Environmental Law and Policy Forum journal, that where Ken Richards at Indiana University summarized dozens upon dozens of different classification schemes for environmental policy instruments. Now, the typeface on this slide is too small to make out exactly what these different classification schemes say. The point here is not to actually see so much the words, but to get a sense for what maybe many of you already realize is that there's a different set of terminology for different kinds of rules that exist in the broader academic literature and certainly in the policy circles, from performance standards, technology-based standards, specification standards, design standards, command and control, market incentives, you name it. There's a broad array of different terminology. And in fact, in starting our committee's work with the National Academy of Sciences, we found that even among committee members, there were different meanings that were being applied to the same terms. For example, performance-based regulation or performance standards, some committee members thought of as an emissions equivalent of, say, an emissions limit, a specification of a very precise outcome that needed to be achieved or an outcome that needed to be avoided. But others, including, by the way, folks at PHMSA who commissioned this study, thought of performance-based regulation as what I have written about as management-based regulation, the risk management plans, for example, under the Clean Air Act, are an example of a rule that requires planning and management activity with the aim of achieving some level of performance, but much different than what an emissions limit would be. This was a continual theme that we found in the committee as we heard from many people. If you could advance the slide, that there's an array of different terms that are being used, sometimes in ways that are counterproductive or keep us from communicating effectively. Advance, please, Paul. So what we really set out to do in this report was come up with a clearer conceptual framework for different regulatory designs, trying to break through some of the existing terminology. And in fact, we, as you will see, created a new type of terminology, not because we felt like we needed yet another set of labels, but rather to provide, I think, what I hope you'll see, a clear connection between what labels we're using and the key differences among regulatory designs. And in some sense also, by choosing some new terminology, we overcome the confusion that can come from some of the existing terminology. Advance, please. So what we did is start with two dimensions of any rule design. And this will be true in any regulatory domain, that a rule design can vary along these two dimensions. The first dimension, advance, focuses on whether the behavior or the command that is reflected in the rule specifies the particular behavior or means that the regulated target or regulated entity must undertake or must avoid. So taking a particular kind of action, not installing a defeat device on an automobile emissions control system would be an example of a means-based command, a prohibition. Or similarly, if the regulation commanded the installation of a catalytic converter, that would be on an automobile, that would be a means-based command as well. On the other hand, an ends-based would just be the achievement or the avoidance of a particular end state that could be, and paradigmatically would be, an emissions limit. So however a car manufacturer wants to design its emissions control system, as long as it doesn't emit a certain amount of pollution above a certain level, then that's a performance standard, as many people would call it, but it's focusing on the ends. Okay, so this first dimension is just to say, let's think about whether the rule is commanding some kind of action, specific technology, some kind of action or means to achieving the end of reducing a problem, or is it mandating the attainment or avoidance of some kind of end state? Okay, advance. The second dimension, though, then focuses on whether either the means or the ends specified in the rule is targeted either to the ultimate problem itself, avoiding a chemical explosion, or to some specific pathway on a causal chain leading to that ultimate problem. So a mean standard that requires a chemical facility to have fire extinguishers on hand is a type of micro means. We don't really fundamentally care about fire extinguishers. That's not the end that we're trying to attain. We're trying to avoid chemical accidents, but if a fire breaks out and cannot be extinguished quickly, that could lead to the larger problem that we care about. That's an example of a micro means regulation that's targeted to a specific causal pathway, as opposed to a macro regulation, which would say don't have a chemical accident or undertake some means that are focused on avoiding that ultimate problem itself, such as we'll see, planning or management activities. Okay, so 2 dimensions, and I think these 2 dimensions capture any kind of design of rule. Now notice, by the way, by design, I'm not going to be talking here about actually what they say. I'm going to give some examples like I've given already about emissions limits or requirements to have certain safety or environmental controls or equipment put in place. But we're focused here on the design. In any particular context, you're going to have to figure out exactly what the means might be or how the ends should be defined. But these 2 dimensions really will be there with any kind of rule design. All right, with that then, advance. We can then begin to think about how a regulatory problem is tackled. And here's a particular very simple causal chain that's designed to show you how an ultimate problem of morbidity, let's say asthma, can be mapped out as a causal relationship between, let's say, asthma being induced by exposure to different kinds of pollutants, maybe the one at the top, sulfur dioxide, the one at the bottom, particulate matter. It's not that there's something intrinsic about particulate matter that or sulfur dioxide that as environmental regulators you're worried about or should be worried about it. Rather, it's because of the problems that those pollutants create for human health or for other aspects of public health and welfare. Okay, that's the ultimate problem all the way on the right, the morbidity. But as we move over to the left, we're seeing different pathways to get to that or tackle that particular problem. If we control sulfur dioxide, we'll reduce asthma, or if we control particulate matter, we can reduce asthma. Obviously, if we control both, then we can reduce it as well. But as then we go back even further, we can see that there's not only the ultimate outcome of morbidity and these precursor end states of pollution levels, but then there's particular kinds of behavior or actions that a regulated entity, an industrial facility, can take to address those precursor end states. It can change to a cleaner input, or it can install some kind of technology in this simplified model here, causal chain. Now, what I hope you can see that already, if we really care about asthma, we could set some standards that either tell companies exactly what means to take to tackle something on a causal chain leading to that problem. So take some action to install some scrubber technology. That would tell them exactly what to do. That's a mean standard. Or it could be an end standard, just don't emit more than a certain amount of particulate matter. All right. As we move back, though, along this chain, one thing to note here, and this is why design matters, is that where the rule falls on the causal chain, whether it's either means-based or ends-based, or how far back it is on the causal chain, will affect the degree of flexibility that a regulated entity has to address the ultimate problem. If all I do is specify a particular level of output of particulate matter, an N standard, then a firm has flexibility either to choose to change to a cleaner input, lower sulfur coal, let's say, or the like, or to install a scrubber. But if I actually tell the firm exactly what to do, then they have less flexibility. All the way back now, all the way on the left on this chart, I wanted to recognize that there's before anything happens, there's thought and planning that occurs, and that too is a type of regulatory strategy, is to try to regulate it at that level. Regulation, in other words, could happen anywhere along a causal chain, and this is just a very, very highly simplified one, just to convey how regulation targets different facets of a particular problem. Okay, advance, please. The two dimensions that we focused on in the report lead then to 4 types of general rules, depending upon whether it's means or ends, depending on whether it's micro or macro. And what I want to do next is sort of walk through each of these 4 designs and highlight what they mean and what some of the examples of them would be, and then I think more pertinently to think about what are some of the advantages and disadvantages of each. Okay, so advance, please. So let's start with micro means. Sometimes people call this prescriptive, sometimes people call this technology standards, design standards, specification standards. The point is that here we have something that's telling a company exactly what action to take or to avoid, and it is targeted at that some earlier point on that causal pathway leading to the ultimate problem. Some of the examples here are drawn from the report, which focused a lot on safety regulation or accident avoidance, but you could see application certainly to environmental regulation here as well. As I said before, an example of prohibition on a defeat device would be a type of micro means regulation, but so would installing a hazard warning sign, installing those fire extinguishers, having a particular type of valve on equipment, and so forth. Advance, please. These micro means regulations have an advantage in that they tell companies exactly what to do. And that makes it, in some sense, easier for them to follow, or at least know what their regulatory obligations are. And for many small firms, often this is a particular advantage because they don't then need to understand that whole causal chain themselves and figure out what the problem is. They just need to install the specified piece of equipment. It may also be, in some circumstances, easier to enforce these type of rule designs as well, because it just requires seeing if the particular mandated technology is being used, or if there's an absence of some kind of prohibited means. But there are disadvantages as well. I mean, creating the one-size-fits-all kind of problem, it may well mean that for some firms, this mandated means is more expensive than some alternative would be. So it may be that, you know, if you've mandated the scrubber in all the firms, some firms could actually switch to a cleaner input and get the same kind of outcome at lower cost. It also may really serve as a barrier and inhibition to innovation because if a particular means is required, then even if some better technology comes along, it would not be possible, absent changing the rule or granting a waiver to a firm to allow them to use that alternative. Okay, advance, please. Compare that micro means to micro ends. Here, this canonical emission standard. Here, we're putting it mandated output at some causal pathway along the way to that ultimate problem. So a limitation on sulfur dioxide emissions and no more than certain parts per million of a pollutant would be an example. Advance. These have some advantages now in that they do allow, as my example of my causal chain earlier suggested, more flexibility. Some firms can meet that emissions limit by installing scrubbers, and others can meet it by reducing their dirty inputs. And it may well also allow room for firms to innovate if they can come up with cheaper means for achieving the same ends. That's great. It may be, though, harder now for the regulator to monitor and enforce, simply because there may be on an inspection an adequate level of performance, but if the regulated entity turns off equipment or changes processes once the regulator is gone, then it may not may not be working as well as if you can have some assurance that a particular piece of equipment or technology is being used, that you know that it is designed to work a certain way and it will work that way. Another problem with performance-based regulations, or these micro Ns, as we called it in the report, would be that it could foster a kind of teaching to the test effect, or some kind of gaming, where firms try to achieve the specified outcome, as Volkswagen did with its diesel emissions testing, met those standards when the engines were hooked up to EPA's testing equipment in the laboratory, but then those engines were designed to operate in a different way on the road. There are the advantages to flexibility from efficiency, but disadvantages as well. Next one, please. Macro means here is what I have called management-based regulation. Here we're looking at influencing how companies are thinking about their ultimate problem, creating internal procedures and planning and risk analysis that will all hopefully be designed to reduce the ultimate problem. So the risk management planning under the Clean Air Act, Section 112, is a good example of that, this type of approach. Toxic Use Reduction Act in Massachusetts and other kinds of pollution prevention planning requirements at the state level are also examples of a macro means. Why means? Well, because they're telling companies exactly what to do. Create a plan, do a risk analysis, engage in some kind of management system. Okay, that's a type of means. Why is it macro? Because the means are aimed at that ultimate problem itself. Come up with an environmental management system aiming at reducing the firm's impacts on overall environmental quality, the ultimate problem itself. It's not a management plan for ensuring that you have enough fire extinguishers. It's not a management plan necessarily for some of those precursors, but it's really aimed at, let's see what you can do to reduce the overall risk. All right, advance, please. These have certain advantages in that they allow flexibility for firms. They can plan and figure out, what are the sources of risk that they're producing and what are the various ways that they could reduce that. There's not flexibility so much on the planning itself, but there's a lot of flexibility in terms of what steps a company might take to actually address its environmental problems, for example. These are regulations that are often used when outcomes are difficult to measure and monitor, particularly for low probability, high consequence events. We see this fairly commonly now. And they may be useful in that they, at least in theory, try to put the responsibility, the onus on the firm itself to think about the problem and to try to develop its own culture of responsibility and how it manages its operations. Of course, it also, like other regulatory designs, has some disadvantages too. For small firms in particular, they may not have really the capacity to do that kind of risk analysis and really think things through. The regulator may you may have to develop some new in-house skill sets to be able to move from, say, an inspectorate that primarily looked at just compliance with certain type of means or ends to now, moving from determining whether the technology is working to whether a company has an adequate plan or management system in place. This can be harder to monitor and enforce, and may be more difficult for certain firms. If you could advance, please.
Carey, we have a question actually from,
sure.
if you don't
Yeah.
mind.
No.
So this is from Paul Ferraro. He writes that most environmental agencies seem to have latitude to change or innovate in the context of micro means and, to a lesser extent, macro means, and power to change micro or macro ends regulations seem to reside with lawmakers. So he was asking whether you agree with his perception that he just stated, and if so, what implications this constraint has for optimal permit and rule design for agencies.
Well, I guess it's going to depend on our environmental legal structure is also divided by specific media, so it may depend on whether we're dealing with air pollution or water pollution, whether those actually hold. I will say that it's interesting that many of you're right that many statutes will require emissions limits. They will also sometimes say that those limits are to be based upon what? The best available control technology or reasonable available control. They're based on technology, but they are to be specified as emissions limits. Now, in practice, what that can mean in some context is that even though there may be a specified ends, that's the standard, that firms may actually just go ahead and adopt the technology upon which that end standard has been based, feeling that gives them a greater assurance that they're doing and there's certainly some critique of existing environmental statutes on those grounds. So I do think, yes, and as I said at the outset, in many contexts, you will be bound by a statute to have to choose a particular strategy, and emissions limits are certainly among those. But there's also opportunities, even in the statute, often to grant waivers or exemptions. Certainly in the settlement of enforcement actions, there may be an ability to impose, for firms to voluntarily assume certain kinds of obligations that might deploy a wider range of these types of regulatory designs that I'm talking about here. I hope that addresses it. I'm happy to take further questions along the way, or certainly at the end as well. Let me just continue then with the macro ends, which is the fourth and final ideal type here, which is really just making sure that a regulated entity avoids that ultimate problem. So, putting in place liability when an accident happens is a prototypical macro ends regulation, some kind of general duty provision, which it's often referred to in the OSHA context, or liability. If you could advance, please. This has advantages in terms of flexibility. It may also help serve as a backstop to other types of regulatory designs, but it may not really be enough to prevent the harms in the first place. Various cognitive biases that firms may be overly optimistic about their ability to avoid the ultimate event. There may be insurance or bankruptcy that may blunt the ex ante behavioral effect of this kind of ex post liability or macro ends regulation, and it certainly does little to give firms direction or guidance about what they can do to be proactive. And ultimately, regulation should be proactive in trying to avoid problems from happening at all. So there's certainly some limitations to this fourth approach as well. Advance. Put it all together then, though, this 2x2 matrix, I think, adequately captures every kind of regulatory strategy that we're thinking about. Even with, I can go through with, if you're interested, and explain how I think information disclosure can be captured in this framework, or even nudges might be captured in this framework as well. If you could go forward, please. Well, I want to make three key observations, Advance, about what I've been talking about, and these are three key observations in the report itself. Advance. The first, that these advantages and disadvantages that I've been talking about are not in any way absolute. They will be both context specific, but also relative to other designs. So relatively speaking, performance standards, or those micro end standards, will be more flexible than a micro means. But on the other hand, if there's only one way to comply with a particular end standard, it might as well be a mean standard in practice. Next slide. The way to think about this relative, I some number of years ago now, almost 2 decades ago, developed this framework to think about basically the three types other than the ex post liability, or the macro ends. How to think about them in relative terms, that when you have, as a regulator, a strong capacity to assess the output, then a micro ends or performance approach is really great relative to any other standard. When all of the firms are pretty much the same and one size would fit all, then a specified mean standard, a technology standard, a mandated technology, or micro means would be a great approach. And then when you don't have either the ability to assess output very well, and you have a high degree of variability and heterogeneity among firms, that's when the macro means or management-based regulation, relatively speaking, will be appropriate. Doesn't mean that any of these will, necessarily do the job, perhaps, but relative to each other, this is when they would be advantageous. Advance. Second is to think about the actual conditions or constraints under which the regulation is being used. If you could advance. And in the National Academy of Sciences report, advance please, we highlight three variables, or three sets of variables to consider as part of the context in which any kind of rule design will be adopted. First, the problem itself. There are some problems where giving regulated entities flexibility could be a really bad idea if there's really a low tolerance for risk, and you want to really have a great deal of assurance that that risk is being addressed. It may not be a good idea to give firms flexibility and have a rule design that would do that. Think about the industry itself. If it's an industry of all small firms, well, that might limit really the advisability of a macro means or management-based approach that puts so much of the onus on the firm itself to do its own risk analysis. And then think about your own internal capacities. As I've indicated, the different strategies will call for different kinds of capabilities on the part of the regulator. Please advance. And finally, the advantages and disadvantages depend not just on which design you choose, but how each design is structured. Let me just go through what I mean by structured. Advance. I mean that not all rules are the same. Advance. Advance, please. Rule design being different than rule structured. Advance. And by structure, I mean other qualities of a rule, the degree to which the obligation is made specific, who bears the burden of proving that the regulation has been violated or complied with, whether it's the regulated entity having to get approval or the regulator having to demonstrate that a violation has occurred. And then what is the targeted location on that causal chain? Advance, please. Here's an example, and if you could just advance all the way through on this slide. A management-based approach can be structured in a variety of different ways, either by just requiring the management activities or requiring those activities and the planning and the implementation. There are rules that vary on that. How specific or precise should the management activities be? Is it just come up with a plan, or does the plan have to have these 8 elements? Again, the burden of proof, does it require pre-approval? What about record-keeping requirements? And how does this interface with or come in combination with other kinds of regulatory designs? Is it the management system all on its own, or management system plus something else? Okay, second example, next slide. And again, you can click all the way through. How well these micro-N standards are defined. Is it a 0.07 part per million, or is it a no unreasonable emissions kind of specificity? That's very loosely specified. Again, where is it located on the causal chain? The closer it is to the ultimate outcome, the more flexibility there will be. So we can't just say that all performance standards will, or micro-N standards will give the same amount of flexibility. It's going to depend on where it is on the causal chain and how much choice really is left to the firm. Are these standards that are met by actually measuring or just by estimating and predicting? Is the standard itself based upon what's ideal or what's feasible? I mean, to what extent, for example, does cost come into play in setting a micro-N standard? Is the micro-N standard set at the individual smokestack level, or is it, say, like a bubble policy set at the whole facility level? That will affect the degree of flexibility. And again, the burden of proof will matter too. These are other features of rules beyond just the basic category of design type that they fit in, that will affect their performance. Advance, please. Now, I want to just say in closing here a few words about performance standards or micro-Ns. Probably many of you already know that there's a preference for this in Executive Order 12866 for specifying performance objectives. When you have discretion in setting a rule, OMB guidance says to follow it. And I think you find around the world a great deal of enthusiasm for performance-based approaches or micro-Ns approaches. Advance, please. But there are, in contrast to what OMB says about the general superiority of these performance standards because of the flexibility they give, Advance, there are nevertheless some limitations. And what are they? Advance, advance. Advance. Okay, first, they don't actually encourage innovation. They allow it, and that's, so you may not get innovation from occurring. There has to be some source for an incentive for innovation to begin with. They don't necessarily decrease regulatory complexity or red tape. I mean, if one looks through the requirements to meet automobile emissions testing, it's a performance standard or a micro-N standard, but there's a lot of complexity to those testing protocols. And finally, they can still be limiting if they're very stringent. Advance, please. And as the National Academy of Sciences report says, that if in a particular context there's only one way to meet a performance standard, it's no different than a means-based standard. Advance. There's some other limitations. Yeah, go through the whole thing. They're great. There's two other limitations I want to just highlight to performance standards. There can be a tunnel vision effect that the micro ends is set on one particular end state, but we actually care about more than that. And we have seen this in a variety of contexts over the years. Initially, child-resistant safety rules to protect kids from opening up medicine bottles and household cleaning bottles and poisoning themselves. They were set just to keep kids from getting into them. And that was great at first, except the only problem was adults couldn't get into them. And so we actually had adults, once they had opened these bottles, leaving them open and kids getting actually poisoned still because of that. And it took a while before we got out of the tunnel vision of just focused on kids to create a standard that was both resistant to children opening it, but actually allowed adults to, and that was built into the standard. Same thing with airbags for auto safety. Initially designed to protect the average adult-sized male, but they actually then killed smaller adults and children. And it took many years before we had a smarter regulatory standard that tried to do both things, like protect people of all different sizes. You can also have this teaching to the test phenomenon that the VW and actually the earlier heavy-duty diesel engine regulatory controversy from the 90s is an example of where firms will figure out, okay, we'll meet the test you give us, but do so in a way that doesn't actually serve the underlying purpose of the rule. Advance. So at the end, I think you have to think very carefully about rule design. Think about the different ways that when you have discretion, that you can fit your rule design to the causal chain for the problem you're focused on. Advance. And consider the different ways. And you may have to combine strategies. One thing we found in the National Academy of Sciences study is that in every rule context we looked at, there were actually combinations. There's no one silver bullet here. Advance. And you also have to think that you're not going to have one design type that will last forever. So be dynamic. Advance. And just go all the way through. I think at the end, I want to just leave you with avoiding some of the simplistic or abstract advantages and really focus on how that design and structure will work in the particular context, given the nature of the problem, given the characteristics of the industry, and given your own capacity to monitor and enforce, and recognize that in the end, you may have to combine strategies or vary them over time in order to achieve the proper outcomes. Okay, I have a couple more slides with references for anybody who's interested in those, but I'm happy to take questions, and I thank you for your attention.
Okay, so we have another question from Paul Ferraro who asks, would you say that environmental rules and permits already reflect the insights from your conceptual framework, or is there a large gap between how rules and permits ought to be designed and how they are actually designed?
Well, I think, again, there are some times when things are hardwired, and the design is is already established, but having a greater awareness of some of these conceptual issues may help with respect to compliance. For example, I think even though automobile emissions standards are something that the agency has to set, recognizing that automakers might actually recalibrate the way a diesel engine is operating using an onboard computer might have maybe earlier turned the country on to what was going on at VW, for example. So I think I think there's opportunities even when things are already kind of hardwired, whether they're optimal or not, to be aware that these different types are out there and they call at times for different degrees of regulatory vigilance as well. There are areas where I think there could be greater flexibility. I'm not disagreeing with the upshot of the OECD or the OMB's claims that flexibility can be a good thing, but I think this framework helps you recognize that whatever approach you are taking, there will be some advantages and disadvantages, and you need to be attentive to those as you go forward and implement those rules or those permits.
Okay. I don't see any other questions incoming right now, so I'm going to take one opportunity to make a plug for the next presentation, which will be August 12th.